Welcome to Forensic Chemistry. I know a lot of folks, this is exciting because this is the course you've been aiming at. You had to go through all these other chemistry courses to get here. And so it's a lot of pressure on me to make sure that it meets your expectations, because anytime people are excited about something, you don't want to let them down. I think it's a great course because it is applied chemistry, and it's an interesting topic. We get into how chemistry connects with society through the legal system, and those are a set of unique problems, to be sure. And so this introductory lecture will be an introduction to forensic chemistry, but in so doing, it'll also introduce you to our course and how it's constructed. So we'll be going through the graphical syllabus today, and then I can answer your questions about any of the details at the end. Let's see. Okay, and so like I said, with forensic science and forensic chemistry, we have all of the capabilities of science, but they're restricted by the legal requirements. And so you've now experienced personal protective equipment like you've never imagined before. And it restricts you, doesn't it? And so just like PPE restricts you and your movement, your dexterity, your ability to communicate, and so on, the same thing with forensic science or legal requirements will restrict the scientific capabilities. We could do a whole lot more as individual scientists than we're allowed to do by the legal requirements. And so we'll talk about some of those restrictions today. Keeps dropping out of PowerPoint. Okay, and so what we're talking about with forensic chemistry is, in particular, applied analytical. So what you've got in your degree is an analytical chemistry degree. We made sure when we developed this degree here at SAM that it wasn't a fake degree trying to just take advantage of the hype. This really blew up, this interest in forensic chemistry in particular, really blew up with the first episode or season of CSI. But you know, a lot of people were complaining about that. But it doubled our majors. Yeah, we went from about 75 incoming majors a year to 150. And so, well, it was actually after we started the forensic chemistry degree, but we started seeing students interested in forensic chemistry, but they were coming in, their only option was just forensic science in the criminal justice area. And you've had some of those courses in your minor, not really intensely focused on the science part, right? Not to throw any darts at them, but we saw a need, and this was slightly before I got here. So this was more than 15, 16 years ago. So probably 18 or 19 years ago, they started putting this degree program together. And they had looked at other universities and what they were doing. And the other universities were sort of cobbling together a couple of courses in biology, a couple of courses in chemistry, a couple of courses in geology, a couple of courses in like medical technology associated with what maybe a medical examiner would do. But the problem with those kinds of degree programs is that you're graduating sophomores, right? You have 2 courses in every discipline and no advanced courses in any one discipline. And so when you get out, you know a lot of trivia. I mean, you know the sophomore level of everything, and you really can't solve any problems in any one discipline. So we decided, the people that developed the degree here decided not to do that. They decided to focus on the laboratory scientist, and a good avenue for being in a forensic chemistry lab or forensic lab is to be a chemist. And so they said, let's get an analytical chemistry degree. Let's add in a criminal justice minor so they understand the legal requirements that they'll be asked to fulfill. And then let's put in a course like this that will touch on the topics that are not covered in the chemistry degree. So that's what this course is sort of to take your analytical chemistry degree that you have now. I mean, y'all are so close to the end, you have it. You know what analytical chemistry is. And let's touch on those topics like microscopy that we really didn't talk about much in chemistry, or talk about the details of, you've talked about organic chemicals, but you haven't really talked much about drugs. And what's unique about drugs? How do we know the difference between a drug and just an organic molecule? And so that's why this is an applied analytical degree. And so you guys could work in just any analytical lab. Like you could get a job in an environmental lab or petrochemical lab, and that happens sometimes. It's very competitive to get into a crime lab. So don't be discouraged, it's just tough. And so the analytical chemistry asks these main three questions: what is it, how much is there, and how sure are you? And so we're going to cover these things in detail, especially the how sure are you. We're going to get into the quality requirements. And then forensics is really the skill, the art, the science of comparison. This is where it separates from analytical chemistry. So an analytical chemist may want to go all the way to identifying what that substance is, but in forensic chemistry, you may be happy with just the legal requirements. In other words, this is a white powder. Is it a controlled substance? If not, you don't care what it is, right? If it's not cocaine and meth or any of these things that will, quote, be against the law, then you're not interested. You're not going to do the qualitative analysis all the way down to what it is. You're just going to compare it to those controlled substances. And if it doesn't hit any of those, it really doesn't matter what it is. Okay. And then there's different levels of dealing with the evidence. So you can identify the evidence, you can classify it. Like I said, a controlled substance would be a particular classification. And then the most fine definition of something would be individualization. So you could individualize it down to a particular substance, but individualization also speaks to individuals. Like this could be blood type, right? Blood type doesn't really get down to an individual, but DNA does. So blood type puts people in certain classifications, A positive, O negative, et cetera, but it's not really individual. It's a classification. And then you get down to DNA, where the biostatistics tells us it's very almost impossible for someone to have the same output in a DNA scan. You're not saying they have the same DNA, you're saying they have the same output from the DNA analysis. And so they're really not mapping your genome. Okay, they're looking at these terminal repeats in your DNA code, and they're comparing them, and so that's enough of a, quote, DNA fingerprint to individualize someone's biological residues. And then the word forensic comes from the Roman Forum. And I just want to take a trip back in history just to think about the advanced civilization that started with Greek society and then even flourished in Roman society, was that the day-to-day struggle for food and clothing and shelter had been satisfied in these large civilizations. Once you get past that, maybe you've heard of Maslow's hierarchy of needs, okay? And if you get up to a societal level of satisfying your lower level needs, then you actually have the freedom to debate. There's no debate in a society where you're trying to get food, get clothing, get shelter. Once you satisfy those, then you reach the level of being able to have the sort of higher order needs met, intellectual satisfaction, art, all of these different other needs that we as humans enjoy. And one of those is focusing on debate, okay, and adversarial claims and hearing out arguments. When you're at the lower level needs, then it's just might makes right. And there is no debate, there is no forum. There's no forensic analysis and no discussion, okay? But once you sort of get to a civilized arrangement of humanity, then you can have this debate about right and wrong, about guilt and innocence and so on. And so that's where this forensic comes from. It goes all the way back to the forum where we would discuss with the Senate, right and wrong and how to organize society. So it's kind of an interesting historical connection there. So in terms of this course, we're going to be talking about the chemistry side of things. So we're focused on the high quality standards that are applied to both biology and chemistry, but most specifically, we're going to be focusing on chemistry, particularly trace chemical analysis and physical evidence, the properties of physical evidence. And then we have a section on quality. So the first section is on quality. And then this is applied to chemistry. So even though it's exciting to think about, the biological side of things, the DNA tests, toxicology, how things are metabolized in the body with specific enzymes, we won't get into the biology as much. Well, really at all, really. We'll talk about what I call baby toxicology. Sort of the toxin is the dose, but we won't get into the metabolics. We will refer to routes of entry into the body, but we really won't get into the details of bodily fluids. We'll talk a little bit about blood in the sense that your analytes can disappear in the blood. So just the enzymes alone will chew up some of your analyte. And so it's kind of difficult to standardize your chemical analysis when your matrix is blood. And so we'll get into some of those challenges and how to make a calibration curve. But really, it's not much biology, it's more chemistry of what's happening in the blood. So these are the three parts of this course. The quality part is the first part of the course, and then the chemical part is the middle part of the course, and then the physical evidence is the third part. And so here's the graphical syllabus, and I've shown all three of those parts, and that's big, the blue, the orange, and the gray boxes. Those are the topics, the lecture topics that we will cover. And roughly the time periods that we're going to cover them in, and then we will have. I'll go through all these different parts as we discuss the course. We have our exam dates there and the percentages of the course. Each exam is 20% of the grade, so there's 3 major exams, and then there's the final that's comprehensive. So there's 4 exams. Each is 20%, and then the other 20% of your grade is the homework and control chart. This semester, again, for the sake of time and sanity, I'm trying to set up homework quizzes that are graded in Blackboard, so that if you're doing the quizzes and entering your answers, you're getting your credit and you move on, and I'm not in the loop. Even in the past where I was having you turn in pages, even though there really wasn't any grading going on, I still had to go in and count the pages and type in a 0, 1, or 2. And y'all were waiting on me to kind of get feedback, even though there really wasn't any feedback. It was just a time waster on my end to go in and kind of give you completion credit. And I always felt like I was behind, and I was, depressed. It's like, look at all these things I got to go in and count, And so I'm trying to move it to Blackboard quizzes that I don't want them to be busy work where it's just go in and click A, B, C, or D. I would like them to be, genuine problems that have numerical answers that you have to work on, right? But the problem with that is Blackboard's real picky in how you enter the answer. So if you just, you get a, 6.2 times 10 to the minus 3 answer, you got to enter that exactly right, or Blackboard's gonna fuss. Okay. So I'll give you a couple of attempts to get that answer in correctly. And then I'm printing off or providing a PDF of that quiz so that you can print the PDF off, work the problems, and then go into Blackboard and enter your answers. So that way you're not sitting there hoping that Blackboard doesn't crash while the exam is up. And again, that wastes both of our time because you got to ask me to reset the attempt. And then, anytime you're waiting on me, I feel bad and you feel bad. So trying to iron all of those kinks out. But that's 10% of your grade. The control chart, which we will talk about the details, is going to have 2 reports instead of a weekly report. And so there'll be a midterm draft, and I'll give you some examples essentially to copy. And this is one time where in writing reports like this is not a research report. This is a quality report. And in that sense, the specific phrases and wording are absolutely open for you to copy, because this is the way they should read. You know what I'm saying? So it's not a report that is creative. It's not a research report, it's a quality report. And you should say, these are the goals of this report. And pretty much everybody should have those exact same goals. And we'll see what those goals are this morning. And then it should say the data was collected this way. Now you might have a little bit different data, so you're going to have a little bit different phraseology there. Okay. And you know, I'll give you a couple of examples and you'll see how similar they are. And so when you look at those example reports, then yours needs to be written very similarly. Okay. And then that's the midterm draft. I will give you good feedback on that draft. And then you have to make, you have to address all of those comments when you turn in your final quality report. Okay. So it's just 2 reports, each one's worth 5% of your total weighted average. So let's talk about this first part of the course. It's a matter of trust. So how do we establish trust in a forensic chemistry environment? So some of the legal concepts or case law that has enabled us to have trust in forensic analyses is this, is that evidence, there's rules of evidence. You can't just bring anything into the courtroom. And you know this if you've watched any crime shows at all. You know, it's not what happened or what you think, it's what you can prove. Well, scientific evidence is something that you've got to get across to the judge, the jury, the lawyers involved, and so on. So you can't bring in anything that's just too outrageous. That's part of the criticism of some of the crime shows, is they'll do outrageous things, and you think that would never get into the jury, mainly because of the Fry rule. So this says evidence produced by scientific analysis is admissible if the techniques are accepted by the relevant scientific community. So this came out in this particular case law to say, look, you can't just bring in a brand new technique. It has no pedigree. We don't know if you made it up just for this case to get the outcome that you want. Okay. You could, you know, just use the weighted arm technique for cocaine. Like, yeah, that feels like cocaine. Scientific test. I'm going to go present that to a jury. You know, that's not going to be accepted by the relevant scientific community. And so then this acceptance can be established most definitely in the peer-reviewed literature. And so here are a couple of journals that you can refer to see, you know, if forensic analyses have a good pedigree, you know, that they have a good background and have been peer-reviewed and accepted. There's also, well, I'll show you in the next slide. But I don't want to skip past if you're still writing. Okay. Everybody ready to move on? Okay. So this is really a great example of what we mean by relevant scientific community. So the National Institute of Standards and Technology several years ago collected all of these things that were called scientific working groups. And so they were SW drug or SW arson. You know, they had different kinds of focuses of these scientific working groups. And these were loose associations of scientists in the forensics field. And the National Institute for Standards and Technology pulled them all together to bolster the forensic science community. And you can look at how detailed they are. Look under chemistry alone, we have fire and debris and explosives. So this is a scientific group of people who that's what their focus is in their scientific careers, is looking at evidence from fire debris and from explosives. You have geological materials, you know, you have mud at the scene of the crime. Well, where did it come from? You know, it looks weird. It doesn't look like it's from the area. So this scientific working group on geological materials would tell you how to analyze that soil. Is it just color? Is it just chemical composition? What about particle size? Maybe you hadn't thought about that, but maybe you need to do a wet sieve of this and see what the particle size distribution is. So yeah, it may be clay, but you've got clay in all these different areas, but what's the typical particle size of clay in this area and for clay in that area? So this scientific working group would give you pointers and tell you the kinds of analyses that are accepted by that scientific community. And you could then point to that scientific working group as the giving you guidance in analyzing these materials. Because I guarantee if you're in the lab and you did an analysis of clay and you've never done one before, I'm going to challenge you on it. Okay. Right? What is your experience? And, you say, well, we use this, accepted technique from the NIST, standards, and we verified it against the standard reference material from NIST. They have standard reference sand, standard reference seawater. They have standard references for just about everything. And so if your technique works against those standard reference materials, then you can have confidence that it's going to work on the unknown. And so that's how you set up this pedigree. And that's about trust. We want to trust your processes before you take someone's liberty away. Another legal precedent is the Dauber Decision. And this governs rules of evidence. It was a federal case, but it's being accepted or adopted in state courts. And it is that the judge has a gatekeeper role for admissibility. And so this is where we get even into more detail. And last time in the Fry rule, it was just about general acceptance by the scientific community. Okay, so that was about the techniques. Okay, this is about the using those techniques as evidence in the court. And it lists criteria such as error rate and peer review. So it also focuses on peer review, but this is mainly the thing to remember about the Dauber decision is that the judge has a gatekeeper role for the scientific evidence. Okay. So we're talking about items of evidence, reports from analyses, and so on. So compare that to the Cuomo decision, which is the next one. It's still the judge is a gatekeeper. So if you're trying to keep these three things straight, the Fry rule, the Dauber decision, and the Cuomo decision, the judge is a gatekeeper in both Dauber and Cuomo. So the judge wasn't listed in the Fry rule. Okay, so that's one way to keep them separate. The Dauber decision is about rules of evidence. So reports from analyses would be evidence. Okay, look at Cuomo. It's expanding the judge's gatekeeper role to expert testimony. So you see how that's different than reports? A toxicology report is evidence. Expert testimony of a toxicologist would be under the Cuomo decision. The report of the toxicology analysis would be under Dauber.
So the Dauber is just data itself, but Cuomo is the interpretation of the data?
The Cuomo is about the admissibility of the expert testimony. Yeah, so the interpretation of that report would still be under Dauber because it's the evidence from the report. But it's if you bring in experts, then the judge is going to want to see what that expert's credentials are. Okay, and this was really important after it became important with arson investigation, but also fingerprint analysis. Those are all very expert based. Okay, now arson investigation has evidence that would be under Dauber, like chemical analysis of the fire debris. That's not what this is talking about. This is about the arson investigator walking through the structure and giving their expert opinion on what they saw, what they observed, or photographs from the scene. So the judge has a gatekeeper role, making sure that experts really are experts. Because remember, we have an adversarial system. Both sides are going to try to bring people into the courtroom that favor their side. And so the judge is the one that's judging whether these experts are truly experts or if they're being brought in just to prejudice the system towards the side that's bringing them in. I mean, we have that cross-examination and so on, but before the expert is even allowed in the courtroom, Cuomo allows the judge to say no, that expert does not have the credentials, or there's concerns about whether they're impartial, or if they're just a hired gun, so the judge can disallow that expert's testimony according to this Kumo decision. Yes.
What classifies someone as an expert in their field? Like,
That's where you're scratching past my abilities. I don't know. So you'd have to go in and dig some more as to what kinds of criteria the judge would use to determine whether someone's really an expert or not. Certainly, time in the field, degrees, what we call pedigree, do they have time in the field and experience would be, I would say, number one. But it's beyond that, I don't know. And so how would a judge know? Well, I'm good friends with the former district court judge here in town, Judge Kramer. And when he got elected as district court judge, he went to baby judge school. So they have these 2 or 3 week trainings that they put the judges through that teach them those kinds of things. And, it would be great. I may ask him, if he has some of his materials that I could use to answer those kinds of questions about what criteria do you use to determine whether, someone's an expert in this field or not. Some of the legal concepts too, in terms of evidence, is that there's inclusive and exclusive evidence. And so we don't want to only focus on inclusive evidence. Let's say if we're working with the mindset of a prosecutor, we want to include this person that we suspect. What about the exclusive evidence? So there's evidence that could exclude you, and there's evidence that would include you as a suspect. And so we've got to use both. We can't be prejudiced against only inclusive evidence, and we can't be prejudiced. Although the defense may want to be prejudiced on exclusive evidence. They're just trying to, we don't care who's included in the suspect list. We know this excludes our client. Okay. And so they can focus on that a little more heavily, but the prosecution needs to make sure that they're looking at both so that they don't unduly put someone at risk for prosecution. There's direct and indirect evidence. And so the only direct evidence is eyewitness testimony. You hear people talk about indirect evidence, they call that circumstantial evidence, as if the circumstances just put my client at the scene, but the more proper term is indirect evidence. Indirect evidence requires inference and logic. Okay. But what's interesting about this is that then the juries are instructed to give no difference in weight. So when they say that it's just a circumstantial case, that's not prejudicial against that case. It's used that way in common terminology, but if you're the only one that had a key to the apartment other than the victim, your car was seen there the night of the crime, the victim was killed with a bat, and you have a bloody bat in your closet. Okay, you have bleached out jeans that you could have been wearing that night. You've got a shoe with a funky pattern on the sole, and there's a bloody footprint leaving the scene. No one saw you there. There's no direct evidence putting you there. But you've got 10 or 12 things that include you as a suspect. And so when people say, oh, it's just circumstantial, that's why that word circumstance is, is sort of a prejudicial term. It makes it sound like it's frivolous. Okay. And everything I talked to you was not frivolous. I mean, those are really strong pieces of evidence that put you at the scene of the crime the night of the murder, including things that are specific to the murder, like a bloody bat and a bloody footprint. I mean, this puts you in there while there was blood on the floor. Okay. So those are indirect evidence, and the jury's instructed to not put any more weight on eyewitness testimony versus indirect evidence. In fact, a lot of times prosecutors will prefer indirect evidence because it's not subjective, whereas eyewitness testimony is subjective. The things that we see or choose to see is impacted by our psyche and our state of mind and so on. And witnesses can be at the same scene and see different things based on their perspective and not even be dishonest about it. It's just their different points of view give different testimonies. Let's see, there's also destructive and non-destructive testing. So when you're bringing in samples to the lab, you need to be thinking about, this is our only hair. Are we going to destroy it in our analysis and not have that piece of evidence again? And so we would want to look at it. Do I really want to dissolve this in nitric acid and destroy the only piece of evidence we have? Or could I use something like an attenuated total reflectance IR that doesn't destroy the sample at all? You know, so there's tests that you can do that preserve the integrity of the evidence, and so how much sample will be destroyed and so on is always a concern. And then your biggest restriction on yourself is this chain of custody. You know, you always have to pay attention to the evidence and where it was, who was the custodian of that evidence, and any kind of break in this chain of custody can raise doubts about the case, obviously. So that's one of the major parts of the course, and that is it's a matter of trust. It's focusing on statistics and quality control. Then we get into chemical evidence. You know, this is answering the question, are you competent? Meaning, do you know about the things, the chemistry related to crime? We'll get into liquid extractions and colorimetric spot tests for drugs. We'll look at how drugs are metabolized in the body to some degree. We'll look at the most common drugs like meth and heroin, diverted pharmaceuticals, and now the fentanyl and the fentanylogs. And then we'll get into some of the evidence related to arson and bombs and nuclear weapons. And so the reason nuclear weapons are in there is, again, some of you may end up not just in crime labs associated with cities or municipalities, but if you end up in the federal system, you're going to be looking at anti-terrorism evidence and so on. And that's also an interesting discussion that we have in this class about prosecuting crime versus preventing crime. And I don't know if you've ever seen Minority Report, but that's a really good movie for thinking about that. You know, they try to arrest people before they commit the crimes. And so it's really an interesting, it's a good Tom Cruise movie. That's a great mind bender. And also it's really, it scared me to death when I saw it years ago. I don't know how long ago it was when it came out, probably over 10 years ago. Because everything was video, face recognition, and like he's trying to run for his life and he's running into a mall, and all of the ads as he walks by the kiosk recognize who he is and use his name and give him individual ads on the kiosks. And we have that now on the internet. You know, you can't watch a YouTube video or surf Amazon without it knowing what you're interested in. You know, I was looking for, I was writing a technical report for Alkanox, you know, the detergent that we have here in the labs. They sent me, I was trying to do a cleaning trial in my research, and they sent me some samples, and they said, if we send you these samples, we would appreciate a technical report telling us how they did. So I'm sitting on the couch and I'm watching some Amazon Prime movie on the Roku, and I'm on my laptop in Google, and I Googled Alkanox because I wanted to see what their range of products were. I couldn't remember the specific product names, and I just needed that for my report. And the very next ad, like 8 seconds later, that came up on the Roku was an Alkanox ad. It was and I'm not surprised that they had it, you know, connected me through AdSense and all this stuff, but I'm surprised at how fast it was. You know, that's what was kind of spooky. And I was like, wow, that's crazy. So that we got down that road because of Minority Report, and we got down Minority Report because of preventing crime. And most of the time we're satisfied with a free society where we're not trying to infringe on someone's rights until they're proven to have committed a crime, right? But when it gets into mass death or mass destruction, then the ball game changes a little bit. You don't want to prosecute somebody after they set off a nuclear weapon. You really want to stop that. And so we'll talk about in this section, the reason I put this in the course is because it develops that tension between preventing crime and prosecuting crime. And I think that's a good tension to think about, because it's got to be a balance. You can't go all the way to arresting people before they do something, but you can't sit back and wait for them to do something if it's going to create mass destruction. So where are we on that gradient? And then secondly, because I worked at a Department of Energy site analyzing explosives and ensuring the safety of our nuclear stockpile, I've got some background in nuclear weapons. And so I would like for y'all to benefit from that, because why do you go to a particular school and study under particular professors if you don't get their particular expertise? And so that's an area where I can provide something that you wouldn't get anywhere else. And so I want to put that in the course too. So with the chemical evidence, this is some categorical things that we don't really talk about in other chemistry courses. And that is these different analysis categories. So you bring in evidence for a general unknown, and you have presumptive tests, which would you get a color change or something like that? You put a spot test on there, and it may be a drug spot test, and you say, oh, okay, this should change purple if it's marijuana, and it changes purple. It doesn't prove it's marijuana, but it does presume. It's a presumptive test. And then you have the confirmation test, category A, and that will confirm that it's marijuana. You also have some screening tests and extraction. So if you do an extraction and it's supposed to come out third in this extraction, and you have a fraction that comes out third, again, it's not really a confirmation test, but it does add evidence. It's a screening test to say, yeah, well, it was a presumptive positive. It came out at the right time, so we think it's still marijuana. It's still passes through the screen. And then you do a chemical analysis in a confirmation test, an instrumental analysis, and you confirm. And so this scientific working group on drugs says that you can have, for a court case, you have to have category A, B, and C, or 2 A's. So like if you skip the presumptive test and go run it on a GCMS and an IR, those are both confirmatory level analyses. And so an IR of the drug and a mass spectrum of the drug, if both of those match up to telling you what that is, then that's all you need to take it to court. And so that's in the chemical analysis, and we'll talk about these instrumentation categories in this course. And then we get into physical evidence. And so we had a matter of trust. Are you trustworthy? Are you competent? And then are you observant? And so this gets down to what I mentioned earlier, particle size, right? It's not just about the chemistry. And in fact, that's what can, it doesn't always, but can separate a generic drug from a name brand. If the particle size is different, you might have a different bioavailability. It might not dissolve fast enough to be absorbed if it's these big boulders of drugs. Now, if you do a chemical analysis, it might be exactly the same chemical. But if the physical properties are important, then you might have a different effect. And in forensic cases, it might have the same exact chemical result, clay versus clay, but the particle size may be different enough to say they were from different regions. Okay, and so the chemical analysis would be inclusive. You say these are in the same category, but the particle size would be exclusive. This would say they're from different categories. And so you just have to be observant. And like these are carpet fibers that I show. Look how different the carpet fibers can be. But if you did a chemical analysis, they might all be nylon or polyester. And you say, well, it's the same carpet because it's both polyester carpet. Really? This could be really important. And if you only look at the chemical signature, you may miss something, and you may put innocent people away, or you may let guilty people go. Both are bad. So we'll get into the physical evidence. And then I talked about the control chart and the homework quizzes. Now, let's see. Okay. Looks like we have 7 people online. I just went with Thursday night because I had to pick a night, but is there another night that you guys would prefer? I'll let you as a class vote to what night your homework quizzes are due, and I can accommodate you. Is Thursday fine? I just kind of did Thursday because we can have Tuesday class and Thursday class, and I can address those topics, and then you can finish up your quiz questions. If you were waiting on Thursday's lecture, you can get that done and then post it tonight. Now tonight's quiz is, I went ahead and gave you an extra week because I didn't want like first day of class, boom, you got to do stuff today, and you're busy getting everything squared away at the beginning of the semester. So week 1's homework quiz is still week 1's quiz, but it's due next week, and week 2's quiz is due next week. So next week you have 2 due. Don't wait till Thursday night to do them, obviously. Do them and submit them anytime, but they're just due on Thursday nights by 11:59. Okay. All right, so we'll do that, we'll keep that. And then let's talk a little bit about the control chart assignment. So right here, this is the purpose. You will put this in the introduction of your control chart report. That the purpose of this assignment is to learn about continuously variable data versus category data or rounded data. And we'll see an example of that here in a second. We've got about 2 minutes. So write quickly. And after, after I think like maybe the week before the exam, I'll go ahead and post all of these PowerPoints so that you have all the filled in blanks. I just want to make sure that you have some blanks to fill in to keep your mind engaged. A lot of the stuff done in a commercial analytical chemistry lab is on a schedule. And so I wanted you to experience this semester having something that you had to do every day and track data every day. And it's really fun because your data will do stuff that's unexpected. So, and then when those unexpected events happen, then you rank an entry, a log entry. Okay, and I will post these particular purposes online. So let's look at 2 or 3 control charts and then we'll be done. This is a very nice control chart. And what I mean by control chart is you're trying to monitor an instrument or a process over time to see if it stays in control. This doesn't have to be something like a large instrument like a GCMS. This could be the temperature of an oven. And at Pentex, we had to age our explosives in an oven for a certain period of time. Well, if that oven goes bad and it cools down, we're not aging our explosives. So are we monitoring the temperature of the oven? We want to check that to make sure. And you would have this little environmental check on the outside of the oven. It was a little wheel with dates on it, and it would just keep the temperature on that wheel. It was a control chart that was continuous. And if the power went out and the temperature dropped, the power came back on and went back up. And so you could say, wow, we had an event last night. The temperature dropped down below whatever, and you could explore. Your action was to explore what happened. So we have a 15-day training period. So the first 3 weeks of data that you will collect will give you your standard deviation and your average value. And then that doesn't change the rest of the semester. So these bars here, the mean, plus or minus 1 standard deviation is the watch limit, plus or minus 2 is the action limit. And you don't take action until a data point jumps out of the action limit. And so the data bounces around the mean, and occasionally it goes outside the action limit, and then you would make a log entry. So let's look at some bad control charts. This is actually if you're doing temperature, it's a bad thing to monitor because temperature is rarely in control, but daily differences might be in control. And so if you're going to do a daily change in temperature, this is a good way to do it. Today minus yesterday, and that's what you would do. You would not do yesterday minus today, because if today's temperature is lower than yesterday, it would be a negative number, and that indicates a drop in temperature, right? If you do it the other way around, if today was colder than yesterday, it would have a positive number for temperature change, and that's not right. It didn't go up, it went down. And so the way you would say that in your report, you would say the previous day's temperature was subtracted from the current day's temperature. So you see the previous day temperature yesterday was subtracted from. It's the one with the negative sign in front of it. People get that mixed up, and I take off points for it every year. And I even tell them every year, this is how you do it. And just to leave it alone. Okay. Gas prices are not good because they're rounded to the penny. They're not continuous. So let's look at those. This is the gas price type control chart. I know it doesn't say gas price, but this is what it looks like when you track gas prices. And so I don't ever allow people to track gasoline prices, even though it's something that we see every day, because it's rounded to the penny. You see those are not continuous on that y-axis. There's really only 4 answers. So this was category data, really. Poor, or bad, poor, fair, and good. You lose the connection to a continuous number with decimal places, right? So this is what we call digitally rounded data or categorical data. And there's this problem doing statistics on this data. You can't assume that it's going to be Gaussian distributed. It's not statistically valid to analyze this using normal statistics because it's category data. And then the last one is this temperature. If you were to just track temperature in Huntsville, this is what hopefully it will do as we get into spring. It's going to get warmer, and that's not in control. If your data is trending, it's not in control. When we mean by control, it's the same. It's in control. It's the same over time. And so if you take temperature difference, then the difference in temperature is probably in control. You have differences day to day, but it should bounce around 0. You have a really cold day and it drops down. And you have a warm day and it pops back up. And you have these differences. And what's essentially by taking differences, this slope drops down to 0. And you have this noise bumping around. And so daily difference in temperature is fine. But, so think about your data, what you're thinking of tracking, and we will, I'll put up a Google sheet that you can put in your idea, and then I'll go in and give you comments if I need to, or I'll just hit approve. And if you get my little initials in the approve column, then you're ready to start tracking. Stocks are good too, doing differences in stocks, daily differences in stocks. They go up and down and they stay in control. But if you do stock price, it's going to trend. And so you don't want to do raw stock price, but you can do stock differences. And it's fun to do stocks. Fellow was tracking Yamaha and the Japanese earthquake and power release and nuclear meltdown and all that business happened when he was tracking that spring, and his data went crazy. But you could definitely see something happened, and you'd explore in the news what happened, and well, yeah, there was a magnitude 5 earthquake and a tsunami and a nuclear meltdown. He had lots to write about. It was great. And so that's it for the day. Thank you all for coming.